Vegetation biomass is a crucial ecological variable for understanding the evolution and potential changes of the climate system on a local, regional, and even global scale. For this reason, it is recognized as one of the 54 essential climate variables used to characterize climate. The largest amount of carbon above ground level is stored in vegetation, but nobody knows exactly how much carbon is stored there. And although measuring the biomass of every single tree on Earth would answer the question, this is unrealistic. From the early days of spaceborne remote sensing, scientists recognize that biomass can be estimated, although remote sensing does not actually see forest biomass. It is generally agreed there's not one single satellite or algorithm that would give the best estimate of biomass everywhere. One of the leaders of several ESA projects devoted to climate change initiative, which plays an important role in attempting to quantify the carbon stored in forests and their feedback to climate, can help us to understand just how forest biomass is studied from space. Just what sort of work do you perform in search of information on biomass and carbon stored in forests?
The idea is to combine all observations taken by several sensors in space to obtain a more comprehensive view on the carbon stored in forests. For example, combine LiDAR information from spaceborne laser instruments with the SAR backscattered intensity from SAR measurements, which is more an observation related to the stem density.
How can all the information derived from these different satellite data streams be consistent with each other?
So each satellite sees part of the problem. Now, the remote sensing community aspires to use all these data streams in synergy. But truth is, we haven't been able to digest all these data streams, this gigantic amount of data. For example, now when we create a map, we only use a part of the data available. So the maps that we create only represent somehow the spatial distribution of the carbon stored in forest, but we do not know exactly how much carbon is stored in these forests.
How reliable are trends in time that we get from maps of carbon based on satellite data?
This is a crucial question in our current research. We do create maps from some observations that are not really related to biomass. So all these maps, they do look similar in terms of where carbon is stored, but we do not know exactly how much carbon is stored in forests. And we are actually pioneering the mapping of carbon globally. The thing is, we look for missions that will truly measure the forests from space and create a long record of observations consistent with each other through many decades.
Are satellites becoming an operational tool to monitor forest carbon and therefore to understand which path climate is taking?
So it's a long way where we're getting there. Space agencies are building satellite missions that will measure forests. And so, with a long record of observations, we will finally be in place to understand how carbon dynamics are evolving and ultimately what is the impact on climate.
ESA's and international missions are playing a key role in delivering novel information about the state of our forests and how they are changing over time. Together with data from the upcoming biomass mission, our knowledge of the carbon cycle will advance greatly.